Subnetting sounds scary, but it's actually just splitting a network into smaller pieces. In the next few minutes, I'll make subnetting feel easy. Imagine you have one big network, and everyone is shouting across it at the same time. Now imagine an office with a few different departments: IT, HR, and sales. If John in sales sends a message, that message goes to everyone in the building. People in HR hear it, people in IT hear it, even though it has nothing to do with them. That's inefficient. It creates unnecessary traffic, slows the network down, and increases security risks. It makes far more sense if messages from sales stayed inside the sales department, and the same for IT and HR. So the question becomes, how do we split one big network into smaller, more efficient networks? How do we improve performance, reduce noise, and increase security? Well, that's exactly what subnetting does. So what exactly is subnetting? Subnetting is the process of taking one network and splitting it into smaller networks, called subnets. To do this, we use IP addresses. Every IP address has two parts: the network part and the host part. The network part tells us which network we're on. The host part tells us which device we're talking to. A good analogy is a postcode and a house number. The postcode gets you to the street, the house number gets you to the door. Let's use a simple example: 192.168.1.0/24. The /24 is called CIDR notation. It tells us how many bits belong to the network portion. An IP address is made up of 4 octets, and the octet is 8 bits, giving us 32 bits total. Each octet can represent values from 0 to 255 using binary. For example, 00000000 is a total of 0. 11000000 is 192. That's because the first 2 bit values are 128 and 64, and 128 plus 64 equals 192. So the first octet of 192.168.1.0 is the 192 portion, and in binary it's 11 followed by 6 zeros. A /24 subnet mask means 24 bits are turned on, and the remaining 8 bits are turned off. When we place the IP address under the subnet mask, we're only allowed to change the bits that are off. That means the first 3 octets stay the same, 192.168.1. The last octet can change from 0 to 255. The lowest address, ending in 0, is the network address. It represents the network itself. The highest address, ending in 255, is the broadcast address. That leaves us with 254 usable addresses for devices. But we don't want one big network, we want to separate departments. When subnetting, we can only create networks in powers of 2. We need 3 subnets, so we round up to 4. To get 4 subnets, we borrow 2 bits. That turns our /24 into a /26. Now let's apply this to our /26 network. A /26 means 26 bits belong to the network, and 6 bits are left for the hosts. Those 6 host bits give us 64 total addresses per subnet. After we remove the network address and the broadcast address, we are left with 62 usable addresses per subnet. Because we borrowed 2 bits, the last octet now looks like this in binary: 11000000. The first 2 bits are network bits. The remaining 6 bits are host bits. With 6 host bits, our subnet size is 64, so our subnets increase by 64: 192.168.1.0, 192.168.1.64, 192.168.1.128, 192.168.1.192, and so on. Before you go, here's a quick challenge. See if you can work out the network address, first usable host, last usable host, and broadcast address for 10.57.2.100/19. Remember, you can only change the bits of an IP address that are off in the subnet mask. The answer, along with the workings out, is in the comments below. Thank you all so much for watching. Subscribe for more IT made easy.